Why is entropy of mixing a spontaneous process? Imagine pouring two different liquids into the same glass. At first, they stay separate, but soon they blend together on their own. Why does this happen without any outside help? That's what we're here to find out. Entropy of mixing is spontaneous because when two or more different substances combine, the overall disorder or randomness of the system increases. This increase in disorder is what we call an increase in entropy. Entropy is a measure of how many ways particles can be arranged without changing the system's overall state. The more arrangements possible, the higher the entropy. Think about molecules and gases. When gases are kept apart, each gas is confined to its own space. But when a barrier is removed, the gases spread out into the entire available volume. This expansion is a process that happens naturally at constant temperature. The molecules now have more room to move and more places to go. Because of this, the number of possible arrangements for the molecules increases, and so does the entropy. Mathematically, the change in entropy when gases mix can be written as a formula involving the mole fractions of each component. Mole fractions tell us how much of each substance is present. When we calculate the entropy change, the formula shows that because mole fractions are between 0 and 1, the logarithm of these fractions is negative. Multiplying by a negative number makes the whole change positive. That positive value means the entropy increases when substances mix. From a molecular point of view, before mixing, molecules are stuck in their own little regions, limiting how they can be arranged. After mixing, molecules are free to move throughout the larger space. This freedom increases the number of microstates, or tiny ways molecules can be arranged, which is a direct increase in configurational entropy. A simple example is perfume. When you open a bottle, the scent molecules don't stay in the bottle. They spread out into the air, moving from a more ordered, concentrated state to a more disordered, dispersed state. This spreading out happens naturally because it increases the system's entropy. In the end, the reason why entropy of mixing is a spontaneous process is because mixing increases the number of possible arrangements for molecules. This increase in disorder aligns perfectly with the second law of thermodynamics, which states that systems tend to move toward higher entropy states. So, whenever different substances come together, they do so on their own because it's the natural way for the system to become more disordered and more stable.